Hi everyone, Mr. Allen here. I had some questions about some of the vector work we've been looking at recently, under subtraction specifically. I thought I'd just kind of talk through a few of these problems to kind of get people going if they were still hung up. First thing to notice, or the first thing that I always want to suggest, is you want to realize I don't expect you to know how to do these questions right away. I've long since said that math isn't about knowing how to do the problem, it's about being able to figure it out given the current understanding that you have. So if you look at this right away and say, I can't express this one vector as a difference of the other two, that is fine, but given what you know, we're hoping you can kind of put together enough information to be able to determine an answer. So if I look at kind of what we know from before, basically we know that the sum of two vectors can always be found by putting the two vectors tip to tail. When I look at this diagram, there's only one location where there is a tip to tail situation, and that's here at B. And so given what I've known from before, vector AB can be added to vector BC. Now the second thing that I know from vector addition is that if I do add two vectors together, the result is a third vector that starts at the same point and ends at the same point. So you can think of this as I have two ways to get from A to C. I can trudge straight through the bushes, or I can go down this road and then down this road, and I'll get back to the same location. Okay, so the idea is that this AC in this case is the same result as going from AB through, or sorry, going from A to B then to C. It's just a different option to get there. So that shows me right away that AB, so vector AB plus vector BC is the same as, is equal to, or gives a resultant of vector AC. So again, this is the knowledge that I have going into this unit, having done addition already. Well, if I'm looking to change something from an addition to a subtraction, what we've done in the past, if we had something like x plus 6 equals 14, we essentially subtract this from both sides and we find that x equals 14 minus 6, which we could then finish up. In this case, obviously, I'm not going to be able to do the quote-unquote finish up step, but the math still holds that if AB plus BC equals AC, then AB can be written as AC minus BC. And now how does that look if I try to actually solve it? Well, I take AC and I subtract BC, which means essentially I take AC and I add the opposite, so I add CB, and then I'm right back to where I would have been with the AB. So AC plus CB is the same as AB, or AC minus BC, because again, minus BC is really just adding the opposite vector on. So there's one option, and of course we could write it the other way as well. We could say that BC is going to be the same as AC minus the AB. Similarly down here, if I look for my key corner here for my addition, U plus W, vector U plus vector W, gives me the same result as going along in vector V here. Same start point, same end point, and so I can turn that into a subtraction in a couple of different ways. That's one of them. So the second question I was asked about was this one. Two vectors are placed tail to tail. Explain why such and such. Now the first thing to say, I know that explain questions are usually annoying. In this case, I don't believe we should be explaining other than maybe to show the fact that this is true. So as a starting point, we'll get a vector on here to represent UV, since that's really what we're trying to determine. And this is vector UV right here. starting at U, end up at V. Again, thinking about what I know, I'm comfortable enough with addition because it makes a bit more sense. If I look at the possible ways to get from U to V, sort of from this starting point to this ending point, given the other two vectors, I can look at sort of going this path from U to O, and then along this path from O to V. So that's what's kind of here. This is the answer from the back of the book. Go along UO, then travel along OV. So UO to OV makes perfect sense. Knowing that we have vectors, we certainly can do this in another order. I was hoping they weren't going to travel together. Let's try this again. So we've got our UO here. We've got our OV here. And again, there's nothing that says I can't do these in a different order. And so rearranging the equation to be OV first, followed by UO is perfectly fine. There's my OV, there's my U to O. And recognizing that really what U to O is the opposite of O to V. So UO, that vector, is the negative of this vector here. We can simply do a substitution to put this in that location. If you want to think of it the other way, of course, we can sort of right off the bat recognize that my first option here, dealing with vector OU, is to go right off the bat the opposite direction. I don't want to go along the path from O to U. I want to go along the path that is opposite to that. Then I want to follow the OV path, and so I get negative OU plus OV gets us to that same UV vector that I wanted. And then, of course, rearranging these so that they match up with the question is a possibility at that point. I think this one's going to be pretty similar. I didn't actually peek at it ahead of time, but I think it looks right off the bat to be pretty similar. The diagram shows a cube. Express EG in terms of AG and AE. Okay, so continuing with what we're doing, I'm looking for EG, so let's establish where that is. That's right across here. And I want to deal with the vectors AG, this one, and let's change it to be a red one, and AE, which I'll make a blue vector. And so I want to somehow add or subtract the red and blues to get to the black one. Now already I've got things lining up pretty nicely. This looks very similar to the question we just did, despite the fact that it came out of the 3D object. You can sort of see, and maybe if I make them a little bit bigger, you'll be able to see even better, that if this is the path I want to take, what I really want is the negative of this blue one plus the positive of the red one. And so the blue one was A to E. I really want E to A. But again, the question sort of suggests I should be using AE, so we're going to go with the negative of AE plus the red one here, sorry, which is A to G, and that will give us the EG that we wanted. Let's pick another one here, HD. So it's kind of 3D coming back at me, but once it's drawn, it's not going to be too bad. So now we have D to B and B to H, and I want to get the result of H to D. And so really what I want is I want to start down here, follow this path, then follow this path. So I want the negative of BH plus the negative of dB, or I guess minus dB, and that will give me the HD that I'm looking for. Okay, so again, I want to go from H to B, which is the opposite of BH. I want to go from B to D, which is the opposite of dB, and the result is that I do the same as if I'd gone straight up from H to D.